All right, this was number 7 on your paper 1, and the trick on this one is understanding what the heck this is saying. So when it tells you that the function has 2 equal roots, it does actually mean that they are the exact same thing. So for example, it would be, and it is quadratic. So I don't know what it is in here, but whatever this happens to be, um, that's what it means by it has 2 equal roots. It's a double root or a multiplicity of 2, and that's also going to mean something graphically for us, but that's what it means when it says it has 2 equal roots. It means it's the exact same thing. Remember, when you have a quadratic, you can have, probably when you talked about in algebra 2, it was either 2 imaginary roots, 2 real roots. This would be having 0 real roots, or 1 real root. But having 1 real root, it means you have to have it be a multiplicity of 2 or a double root. And that's what this may be the British way of saying you have a multiplicity of 2 or a double root. So it means you have to have 2 equal roots. So for us, what that means is, if you think about a quadratic and the quadratic formula, what it means is that the discriminant, which is the b squared minus 4ac, the thing underneath the square root in the quadratic formula, has to equal 0. That's the only way to end up with a single root. That's a repeater, because this is your opposite of b plus or minus all of this. And so the only way to get rid of the plus minus, which is what gets you the 2 in these situations, is for this value to equal 0. So if that has to equal 0, then I can come up here. This is my b value. And this was the mistake a lot of people made, that negative 4p is your b value. So that has to be squared minus 4. A is p, c is 1, so I'm not going to write it. That has to equal 0. And what happened is a lot of you chose not to square the 4. So this would actually get me 16p squared minus 4p equals 0. Some of you did this and used quadratic formula to try to figure out what the values were. You could also factor out a 4p, and that would leave you 4p minus 1 equals 0. And so the possible values for p would be p equals 0, which is what you would get here, which doesn't make any sense, because if p were 0, this wouldn't be a quadratic, so that solution's garbage. Or this one right here, which would yield your p value of 1/4. And that's what the answer is, 1/4. And so that's kind of the approach, is realizing you have to set the discriminant to 0, and then that this whole piece is your b, and so you've got to square that 4. Part B says a line intersects the graph. Find all the possible values of k. So this is just a horizontal line. Y equals k is a horizontal line, and I want all the possible numbers that could be put in here to create all the horizontal lines that would intersect the graph of f. What we talked about, this is the form it would have to be in for this to be have exactly 2 equal roots. So graphically, what that means is your vertex has to be on your x-axis. You can't cross it twice. You have to have a turn on the x-axis. That's what that square means. So I can answer this without even doing anything other than recognizing that p is 1/4. So if p is 1/4, it's a positive. That means my parabola, I don't know exactly where it's located. I'm not going to really mess around with that. All I know is it's a parabola that opens up, and the vertex has to be on the x-axis, which means that horizontal lines, this could cross it, crosses it, crosses it, crosses it, crosses it, crosses it. Every single positive value of y will cross it, including a y equals 0 value would also intersect the parabola. So my values for k, in essence, are greater than or equal to 0. Some of you did it in interval notation like this, but it's really just anything bigger than 0 would be a horizontal line that would intersect it. And that's the way I worked out number 7.